We're going to take a look and see how we can use a spreadsheet to make our data tables for our lab and to graph the data that we've collected. And once you guys learn how to do this, you're going to love me, because I have taught you one of the greatest things you'll ever know, which is spreadsheets. And you can see that I use spreadsheets for all kinds of stuff because obviously I'm a nerd and I love this stuff too. But the spreadsheet that I'm going to teach you to use is a Google Docs spreadsheet. You can use Microsoft Excel, which is basically the same thing, but I like Google Docs because it's free and it stores it for you in the cloud. Now the first thing you want to do is go to the Google Docs. Now if you look over here, it says Drive. If you click up here once you sign into your Google account, and you'll see your apps, they have replaced the Google Docs with this thing called Google Drive. And if you click on it, it brings you basically to where your Google Docs page used to be. And we are going to create a new spreadsheet. And what you notice is just a bunch of boxes. It's a grid. And you've got columns labeled with letters and rows labeled with numbers. What a spreadsheet does is allow you to put either text or numbers into these boxes. And what makes it interesting and cool is that when you enter numbers into these boxes, you can make the spreadsheet do calculations on those numbers. So for instance, you guys are doing a lab on Newton's second law, and there's a lot of different data that you're collecting and a lot of calculations that need to be made. You kind of have to do a little pre-planning here, because one of the things that is important is when you go to graph it, you're going to need the data that is your y values and your x values next to each other. So I'm gonna come out here several spots, and I'm gonna create those columns first. Now our first one is we're doing force versus acceleration, and we want force on the y-axis. So I'm gonna type in force, and I'm gonna put in the units, and then next to it I'm going to put acceleration and its units. And unfortunately, we don't have a lot of leeway on our ability to do subscripts and things like that. But what we can do is use the universal caret symbol for squared. It's kind of old school, but that's the best we can do in a spreadsheet, as far as I know. I could be wrong. Correct me if you find out differently. You notice I put the units in here. The values we're going to have in these columns can't have units in them. They're just numbers. You can't do operations and calculations based on anything that has a text in it. So you can't do calculations based on these two text boxes. And if you put units in with your numbers, it's not going to work. The force and the acceleration in this experiment are calculated values. The calculations for force, if you recall, the force was a variable, and it was based on the mass on the hanger, and it was multiplied by 9.8. So I'm going to create a column called mass of hanger, which is in kilograms. You notice I can resize the columns to fit the text if I want to. And I'm going to put some numbers for that in there. Other data that we got. Acceleration, how was that calculated? Well, if I recall, it was based on the distance that the cart traveled and the time it took. So I'm going to make a distance column, and I'm going to make a time column. But the thing is that you were going to do several different trials with your stopwatch to get an average value. So I'm going to call this one time 1, time 2, time 3, and finally an average time. Then we're going to do some calculations based on these numbers to come up with these guys. Now I'm going to pause for a second and enter in my data. So here's the raw data that was gathered by this group. Now there's some things I should point out. They did not write down their masses in kilograms, but you know what? That's okay. We can change this and do the conversion in the program. You'll see what I'm talking about in a second. Also, their distance, they measured them in centimeters, which again is fine. We can make the conversion later, and that's what we're working our way up to. And you notice the distances are the same. That was the thing that's one of the constants in this. The other constant would be the mass of the system. One of the things that we need to do if we're going to calculate the force is we know that we need to multiply the mass times gravity. So what's fun about this is I can create a formula to do that. You start all formulas with an equal sign. What we want to do is multiply the mass. I just go click over here where the mass is, and you notice it says A2. That's because that mass is located in cell A2, and we're going to multiply it by 9.8. Now the only problem here is these masses are in grams and not kilograms. So part of the conversion would, you'd have to take that mass and divide it by 1,000. So I'm going to go back here and I'm going to insert a divided by 1,000. Okay, so that little bit there is the mass in kilograms multiplied by 9.8. Let's see what we get when I hit enter. I get 0.049 newtons. Okay, now this is so cool. You think, oh, I got to do that for each of these cells. No, you don't. What's really neat here is at the bottom right hand corner of each cell is a little square. When I hover over it, it becomes a crosshair. If I click and drag that down, it copies the formula down. But what you might notice is now it says A3 instead of A2 like it's set up here, because it's what we call a relative copy. And so it copies it down relative, so each row is calculated separately. And now we see our forces. Okay, now over here, we want to average our times. Now we all know that to average the times, we would we'd add these 3 times together and divide by 3. What's even cooler is we have functions. If you go over here where it looks like a sigma, and I click over here and pull down, I see this word average. I click on that, and I tell it, by clicking and dragging, I want to average these 3 numbers. And then I hit enter, and it gives me the average. And once again, if I grab the bottom right hand corner and drag it down, it copies it. Isn't this cool? Look at what a time saver that is, you guys. And then finally, acceleration. The formula for the acceleration was that it was going to be the distance over time squared. I'm going to click over here, hit equals, and I'm going to type in distance, except for the distance is over here. So I click on that. Now remember, we need it in meters. Now to convert from centimeters to meters, I need to divide by 100. So I'm going to type divided by 100. And by the way, the slash, if you didn't already know that, is the division sign. And then I'm going to take that number and divide it by the time squared. I could use parentheses, I suppose, and I will, just to make it easier to see what's going on. I'm going to divide that by the time, the average time, which I click on because it's over here. And then universal symbol for an exponent is the caret symbol. It's above the 6 key. And then I'm going to put a 2 for squared and another parentheses, and I hit enter, and that's my acceleration. And I'm going to drag it all the way down to the bottom. One of the things that you may be noticing is that there are just way too many significant digits on our times and accelerations, and there is a way to fix that. I'm going to drag and select all these in this column, and if I go over to here where you see the formats, I'm going to format this where it says, see where it says decrease decimal places? I'm going to just keep clicking on that until I see something reasonable, like maybe that. And then I'm going to do the same thing over here on the acceleration. I'm going to decrease the number of decimal places until I get something that isn't so psychotic looking. How about that? Look at this. I have my force and my acceleration. Now, what's so wonderful about that? Well, now we get to graph it. And I'm going to grab both columns. The force is my y, the acceleration is my x. And I'm going to go up to here where it says insert chart. When I click on that, it gives me some options. And the options that they give you right off the bat usually are these kind of financial options. Well, we're not doing finance. So I'm going to click up here to charts, and I'm going to go to scatter. In science, we always do scatter. Scatter means we're going to plot x's and y's. And then I click on the one up here, scatter chart, and I'm going to hit insert. Now, this may look a little funky. It is a little funky because we are not seeing much going on down here. What I see when I look down here is that it looks like it's flat. And part of that is we've got this massive outlier here that is kind of causing our scale to go way off. And so what I think I might want to do is try to go back and maybe ditch that data point. Okay, normally you do not want to ditch data points, but this one just seems extremely out there. As a matter of fact, the one before it seems a little out there too, though you may even want to get rid of that one. Part of the reason is, as you can imagine, that as you put more and more mass on the hanger, that thing is flying down the track and your inaccuracy just goes up, 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 up. So if I go back and I'm going to delete this chart, this time I'm going to select down to here and go through the same process. Insert chart, and I got my scatter plot, and I hit insert. Hey, now there's something. That looks a little bit more like the linear thing we're expecting to see. Now some of the things you can do with these charts, for instance, is you can make some edits, like for instance the chart title. So I'm going to say this is force versus acceleration. Also the horizontal axis title. The horizontal axis is the acceleration. And of course I put units. Now I've got that axis labeled. Now I notice there's no way for me to label the y-axis. If I go into advanced edit, find at some point where I can, where it says axis, if I pull down on that menu and make left vertical and make a title, force in newtons, and hit update, now all of a sudden I have my nice little label here. This is a beautiful graph. This looks like a fairly linear graph, which we were hoping to see. At this point, if you wanted to print this out, you could go to the print part. Let's see, where is it? There's the print. And we are going to click on selection. And then if I print that, I will get a print of just this chart. Now, one of the things that I'd really like to know about this chart, and by the way, I can move it, is I'd love to know what the slope of this data is. And so I'm going to create a new place over here. I'm going to call it slope. To the right of it, and you could do this any way you want. I'm just making something. If I wanted, I could just put it up here. And I'm not looking for the slope of a single point. I'm looking for the slope of the entire data set. If I come over here and go to functions again, there is a function in here somewhere called slope, I believe. And it shows you how to format that. So that what it looks like is what we're going to do is we're going to say slope, parentheses, data y, in other words, the y-axis values, comma, data x, the x-axis values. So if I go back to my spreadsheet, so any kind of formula, it always starts with an equal sign, and I'm going to hit SL, and you notice by the time I get an L, it gives me a couple things I can pick, so I'm going to hit slope. Now remember, my y values are this column, then I have to put a comma, and then I can select my x values, and then I hit another parentheses, and I hit enter, and that's the slope of my line. And that's the actual statistical slope based on a linear regression of this data. And I think we figured out that that was supposed to be equal to the system mass. So if you look at that, 0.6889, let's reduce the number of decimal numbers on that. That is supposed to be the system mass, which that'd be about 689 grams. And if you think about the fact that the cart was 500, the hanger was 5, and then you had all these different values in here. As a matter of fact, the maximum amount we used was 105. So 5 plus 105 plus the 5 is about 610. So we're off by a little bit, but actually this is not too bad, and we're going to be able to compare that and talk about why is it off and why is it a little high. Why does the mass seem to be higher than it really is? That's going to be a point of discussion in our conclusion. If you want to get really fancy, you could actually compare that slope to the mass of the system. This is just, you could just nerd out all day on this stuff. It's kind of fun. And I probably should put that my slope is also in kilograms. So we're comparing apples and apples. Now I said that based on what I saw over there, the mass of the system was 610. Now what if we wanted to find a percent error? We know the formula for percent error. I take the measured value, subtract the known value, so the measured, actually I need to do this parentheses. Take the measured value minus the known value and divide it by the known value. Click on that again and hit enter. And that's my error. And if I click on this and go over and click the percent sign, oh, there's my percentage. See how crazy you can go with this stuff? This stuff is awesome. This is how we use a spreadsheet to not only do all the calculations on our data, but to create the graph and analyze the data that we have. And one more time, I'm going to move this over here. And at some point you will, print some of this business out and turn it in with your lab report.